Hey, welcome back to another TouchDesigner tutorial. I'm super excited to finally get to launch this component that I've been working on that allows you to run real-time body tracking in TouchDesigner on Mac and PC with just a webcam. So here's a couple examples of things that I've created using this plugin. So for the first set of visuals, I was actually tracking the distance between my hands, and I was using that to control how much effect the audio was having on the visuals. And then I also was using that to apply a low pass filter to the audio as well. For the second set of visuals, for the particles, I was controlling the size of these spheres that I was using to basically paint the particles, and those were mapped to the velocity of my hands. I'm going to have the plugin available on my Patreon, as well as this entire project file, so you have access to both of the examples as well. I'm also going to do a follow-up tutorial on both of the different examples to just show you how to create those from scratch. For today, I'm going to show you how to set up the body tracking plugin and just show you a couple of quick examples and some of the core details so that you can get it incorporated into your own project. So if you've seen my tutorial previously on body tracking, this component is actually a bit different. When I was building this component, I really wanted to be able to use it for installations. So it is still using a website internally, but what I've done is I actually have all the machine learning models downloaded and the website downloaded, and I've customized it so that it allows us to be able to run everything locally and as well like start up the project from scratch and pre-select your webcam, pre-select the ML model that you wanted. I really wanted this to work offline so that way you didn't need an internet connection and it would just work out of the box. When you go to download this project file, you're going to get three things. You're going to get the actual .to file, so that's this whole project that we're working with. You're also going to get this body tracking .tox. That's this standalone component if you wanted to just drag and drop it into your project. But the other thing is that there's this dist folder. So I want to make sure that this dist folder needs to be at the same location as your .to file or as your .tox file. And the reason for that is that this is actually all of the data that's used for the website to be able to load the ML models. So you'll notice in here, we actually have the different models that are available. You can see there's the Blaze, Lightning, MultiPose, and Thunder. There's no way for me to kind of like bundle all of this up and put it into the component. So the best option that I had was to kind of store all of this website data here. If you're doing any network related stuff for your project, one thing to note is that these are the different network ports that are being used for the project. If you're not doing those, just leave them as is, and everything will work as intended. So I've worked with a lot of different Kinect projects, and one of the things that I found really tricky is that it actually takes a fair amount of setup in order to do something like track where your hands are, or get the velocity of your hands, or even just do something like instance to be able to render out your graphics. So one of my big considerations for this component was to basically have all of that prepped and ready for you to use out of the box. So you'll notice that there's three different outputs here. And basically what we get is the joint data. This is all the positional data that you can see here that's being tracked in real time. And you get all that normalized from 0 to 1. And so you can map it to whatever range that you want. The other thing that I did is I actually added in some nice little helper pieces here for tracking the velocity of your hands as well as the distance between your hands, because those were things that I kind of found I wanted to do in a lot of projects. So that's prepped for you. And then similarly, I also have all the data formatted so that it's ready and instanced. So that way you have the X, Y, and Z positions for your pose data, and you can basically render that really efficiently. Okay, let's go ahead and dive into the actual body tracking component. So if you click on it over here and you open up the parameters page and go to the custom tab, you'll notice that there's an option for webcam. So here you're going to set up your webcam to whatever one you want to choose. And once you set it, you're going to actually need to wait for this component to show up with the webcam here. And once it shows up there, then it's actually ready. If it's not showing up by default, you can always hit this little reset button, and then it takes a little bit of time to get started because it actually has to spin up a machine learning model and a browsing environment. But then once it's ready, it should be good to go. You don't actually need to change any of these options over here, but the other one that you might want to look at is the model. So there's a couple different options that are available for us, and there's different trade-offs for each one. So the first one we're going to look at is MoveNet Lightning. MoveNet basically gives us positional data, and it only gives us the X and the Y. So there's no depth. And you'll notice if you look at the joint data, for example, I'm going to actually put down a select chop, and we're going to take a look at just the player one's joint data. So if I zoom in, you'll notice that we have player one, we have like the nose X position, the eye, all the different X and Y positions, and then also the score. And the score is basically telling us how closely or how accurate it thinks that its estimate of that position is. And that's actually super helpful because you'll notice that if we look down here, some of the points might be kind of jumping around, and it's rendering all the different points right now, and it actually is adding in the points for my legs, but the score is quite low. So you could actually use that data to determine which points you want to render. The next one that I want to look at is MoveNet Thunder. So this is basically a trade-off between the performance and how accurate the points are. So Thunder is going to be a little bit slower, but it's going to be more accurate. So the points aren't going to jump around as much. You might have noticed that there's multiplayer render. And what we can do is there's actually another model called BlazePose. If we select this one, it's actually using Lightning. So it's not quite as accurate, but it's going to be outputting player data for up to 6 people max. And again, this is only the X and Y positions. So that's why you'll see here in the joint data, that's why I ended up selecting out the player one data only. All the other models are just for a single player, but this is a nice one where you can actually play around with that. When you're using the BlazePose, if you look at this little player render, this is a helper component that I made for instancing where I basically set up a unique color depending on which player data is passed in. So here you can color player one. Let's just give it a different color. You can see player one is now pink. I can go back to white. And then you can give a unique color for each different player's data that's coming in. You can see I'm getting these extra points up here because those are probably, it thinks those are my feet or something like that. And you also could optionally render the points again based off of the score. Next up, I want to take a look at the BlazePose. So BlazePose is really interesting because it'll actually give us the Z position, and we can use that for depth. So again, the light mode is going to be less accurate, but it's going to go much, much faster. If you take your TouchDesigner project and you set the frame rate at 120 frames a second, you could potentially render it, depending on your graphics card, quite high. It's a little slow for me right now, mainly because I'm recording the video and screen recording at the same time. So that adds a little bit of overhead, but I found it to be quite performant. Okay, so BlazePose Light is going to be a little bit less accurate, but you'll see we actually get more positional info. So we have a lot more key markers on our face, as well as our hands and legs. So there's way, way more markers. And you'll see that our joint data actually changed. If I look at the player one data, there's way more key points over here that are available for us to use. The only difference here between the light, full, and heavy are kind of what you would expect. So full is going to be a more accurate model, but it's going to take a bit more overhead for computation. And then heavy is going to be a heavy model, more computation, but much more accurate. So I found that full has actually been really, really good on my end, just running off of a M1 Mac. And I've been able to get a great frame rate out of it with really, really accurate response. I used this model to record the different videos. All right, so the first thing that I want to show you how to do is how to just take some of the joint data that we're getting from the model, and let's go ahead and just like move a sphere around the screen using that. So I'm going to go ahead and select out player one's like wrist X, and let's go ahead and place down a select. And then we're going to get any channel that has P1 star. And if we zoom in, we can see that there's a lot of options, but I think here I can see P1 left wrist. So let's do P1 colon left underscore wrist star. And notice that we basically have the left wrist's X, Y, and Z position and the score. So I'm gonna get the right wrist as well. So we're gonna get P1 underscore right wrist. And there's pretty much all the info that we need. Okay, so now that that's kind of isolated, let's go ahead and maybe make a circle top. And I'm gonna set this to use the resolution of the parent panel size just so that it kind of scales nicely. And then I'm gonna set the radius a little bit lower. And the thing that's nice about this is if I move my hand around, the way that I've actually set up the coordinates is that it's gonna go from 0 to 1. Even though some of the values are negative right now, it's because they're kind of like off the screen. Like my hands aren't in the frame right now, but you'll notice like once I put them in the frame, if I move them up, you'll see both Y values go to 1. And if I move them down to the bottom of the frame, they're gonna go to 0. So what we can do here is we can go ahead and place down a null. I'm gonna place down a transform, and we're gonna use the transform to move the circle around. One thing to note though is that the circle kind of goes from negative 0.5 to 0.5. So I think we're gonna wanna remap our ranges for those. So I'm gonna put a math down, and normally the values go from 0 to 1, so we want them to go from negative 0.5 to 0.5. Now, I'll delete that null. I'll put the null afterwards because we're gonna pass a reference between a chop to a top. I'm gonna pass a reference for the left wrist onto the transform. And we're gonna put that on the X direction, and for the Y, pass that reference. So now if I hold up my left wrist, you can see it's moving around nicely. And maybe we'll just duplicate this, and we'll set this up to use our right wrist. So I'm gonna go ahead and just open this up and modify the expression to use right and right. Okay, so now, cool, we've got those two. Why don't we go ahead and composite them together? So we could just add them together, I guess, why not? And now we've got both of them in the frame. I'm gonna make an RGB key, and then I'm gonna set this as our background. One thing I wanna show you is that if you go to this body tracking component, if you go to the player settings, there's some nice little pieces that you can potentially use. If you need it, I already have a lag component in here, and so there's this movement easing lag. So if we tack in like 0.4, 0.4, now there's like a lot of smoothing and easing that's applied to our wrist movement. Or you could set it back to 0. So now there's no easing applied. We're kind of getting the direct input from the model. The next thing that I want to show you how to do is how to use the velocity. So in the hand data over here, notice for P1, I have left hand velocity, right hand velocity, and the distance between hands. So these are some little pieces that I tossed in for you out of the box. Why don't we map the velocity to the radius of the sphere? So this is already a null, so I'm just gonna go ahead and click on our sphere. This is our right wrist, so circle 2, and I'm gonna grab the velocity of the right hand is gonna be our radius. So I'm gonna drop it over the text radius so that it'll attach it to both, and then I'm gonna click chop reference. So now we've got a reference to it. So let's go ahead and see with our right wrist. Oh, it's huge, okay. Maybe let's take this whole expression and multiply it by like 0.3. And I'm gonna do that for the radius X times 0.3 and Y. So now when I move it, you'll see that depending on what the velocity is, we're getting some nice easing there. And we can do the same for the other one. Let's go ahead and take our other circle. I'm going to pass in the left hand velocity, and I'm gonna multiply this by 0.3 times 0.3. At this point, it's probably good to put in like a little constant so that I could just easily change it in one place, but this will be fine. So yeah, check this out. The other thing that I've done that I want to point out here is that I have easing on the velocity that's quite high. And I just want to make sure that you can kind of see if I make this low, the velocity is quite jumpy. So you'll see it's pretty sporadic. So I have a fair amount of easing that's applied to it, and that way it animates much more smoothly. The other thing that I wanted to show you is how to control something with the distance between your hands. So here, maybe let's just make another third circle, and instead of this one getting moved around, this one is basically just going to take on the size based off of player one's hand distance. So I'm going to pass a reference to the radius of this circle, and let's go ahead and see. All right, so one thing to notice too is that, okay, my hands are out of the frame, right? but it just went back to 0. So there's a couple of things that you can customize here. What I have is this wrist score threshold. So the distance between your hands is going to default to 0 unless the score for your hands is above 8.27 right now. If I make this even lower, you're going to see that suddenly the distance pops in, even though my hands aren't in the frame. So I set this up so that, most likely, like if your hand's out of the frame or if the player's not on the frame, you probably don't want that distance calculation. So you can adjust this accordingly. And then once my hands are in the frame, now it'll calculate it. Ta-da. Similarly, there's also a minimum like a default distance between your hands. So if you increase this when your hands are out of the frame, that's what the default value is going to output. Another quick thing to note as well is that for the player data, this is applied to all 6 players, even if you're in the multi-pose setup. And then obviously this flip X button, since I haven't shown that yet, but you can see this will flip the X and Y, or the X positions. One last thing that I didn't cover is the pose threshold. So in the player settings for the body tracking component, notice that it's at 0 right now. If I start to increase this, this is basically looking at the average score of every single point. And what'll happen is it will default all the player data to 0 if it's not within that threshold. So notice as I start to increase this, suddenly all the player data goes to 0. So this is here if you're doing an installation and it's kind of picking up some stuff in the background that it thinks might be a person, but the score is quite low. You can kind of increase this a little bit. I will say the MoveNet models tend to have a lower score. So I would actually recommend having the pose threshold quite low, especially if you're doing multiplayer. Okay, so the last little thing that I want to show you is just how I'm doing the rendering setup right here. Basically, this instancing data, you'll see that we're only getting data for the XYZ and score of player 1 because we're using the BlazePose full model. And even if we went to the multi-pose model, I wouldn't get any extra data because it's just me in the frame. One thing I want to show you as well is that if I switch to Thunder or any of the MoveNet models, notice that once that data starts coming in, it's got to load. Notice that now suddenly the Z data disappeared. So we have X, Y, score, and name. And if we go back to the Blaze, now we get the X, Y, Z, and score. Okay, so I want to really quickly just render this data. So what I'm going to do is I'm going to select out just the player 1's information, which is the X, the Y, and the Z. And we can instance with this. A really, really simple way to do this, I'm actually, just because I know that there's an instancing network inside of this, I'm gonna actually use the point cloud render component from the palette, which is in point clouds, render, it's already open. So this is looking for top data. So what I'm gonna do is right click here, go to tops, chop to. So this is gonna convert our chop data into pixel information as a top. Now what we need to do is convert our data to use red, green, and blue. And basically what we're doing is we're treating our X, Y, and Z values as red, green, and blue pixel data. And then instead of using a single row, we're gonna fit it to a square. And if we pipe this in to the first parameter, notice that we get some points rendered, and then we can actually increase the point size. There we go. Ta-da, we're rendering. So this is like a really easy way to be able to visualize that data. And again, that's basically what the single player is, but all I did is just took the extra time to pass in the chop data for instancing. So one of the last things that I wanted to show you how to do is how to also work with your own video and piping that video into the body tracking. Because right now we're just using a webcam, but let's say that you wanted to process some video from TouchDesigner. Go ahead and place a movie file in, and select a video that has some type of motion or a person in it. And then what we want to do is we actually want to get this over to another piece of software called OBS. And I'll put a link to this software in the description. But OBS by default doesn't actually pick up this video. What we need to do is use another software called Spout or Siphon. And there's a built-in component for it in TouchDesigner. What this will do is it will actually optimize sharing this video to other software. And what we can do now is I can open up OBS, and what you'll do, start off by making a new scene, And then here in the plus mark, you're gonna go ahead and look for either the siphon client or the spout client, depending on which operating system you're on. So I'm on Mac, so I'm gonna open up the siphon client. And if I open that up, you'll see here, if I click this drop down, that there's TD siphon spout out. So I can pick up this texture. I can go ahead and hit OK, and then I'm gonna resize this to whatever fits nicely. And the last part is starting a virtual camera. So once I start the virtual camera, this is basically going to show up as a webcam device. Now in the body tracking component under custom, so if I select OBS now, it's going to select this new webcam device, and it's actually picking up the information from the video now. So this should be playing back in pretty much real time and coming in through the webcam here. So hopefully that gives you a nice way of kind of playing around with other video data as well. Thanks again for following along. I'm really excited to see what you're going to make using this component. Let me know if you have any questions in the comments, and if you enjoyed this content, consider giving it a like and subscribe. And keep an eye out for the next 2 tutorials where I'll be showing you how to create the visuals that you saw earlier. So this set of test visuals as well as the particle system. Till then, thanks again. Look forward to seeing you in the next one.